Do you know how to save space, time and energy? Mathematicians always do that. These are notations, and in this video we are going to see some notations of groups. Notations. And you are also familiar with this. Instead of writing the set of integers, instead of writing this whole big thing, we only write this symbol, and this represents the set of integers. This represents the set of natural numbers, the rational numbers and so on. And we are familiar with the notations. In this video we'll see some notations of groups. I will make 3 columns. The general notation, general, we have 3 columns, and next we have, let me separate this column. Next we have multiplicative notation, and next we have additive notation, additive. First one, in generally we can use any symbol. We used to use star, or we can use composition symbol, or any symbol. We can have a happy little emoji, we can use also. In generally you can use any symbol for the binary operation. Here what you have, we have dot or multiplication, and this symbol is read as multiplication. Multiplication. Here we have addition. To use multiplicative notation of a group, we use only dot or multiplication symbol. For use additive notation, we will use plus, and this is our first row, and we wish to write A star B. Here we will write A dot B or AB. Anything you can use. AB means A operated with the element B under the operation we have, and here we have A plus B. Read it as product of A and B, and this will be read as addition of A and B. Addition. This is our second column. Next we have, for identity, we used to write whole thing, identity. Here we will use 1. This symbol will represent the identity. 1 is not the integer 1 or the real number 1 we are familiar with. 1 stands for the identity of the group, G, if G is our group, and under on the symbol multiplicative notation. In additive notation we have 0, read as 0, and 0 is not the usual 0 you are familiar with. 0 represents the identity of group, any group under the additive notation. This is our next row. Now we have inverses. For inverse of any element, we have to write the whole thing. Inverse of A, and it will be reduced to only symbol a inverse, a to the power minus 1, and it will be read as multiplicative inverse of a. So this is not 1 over a, this a to the power minus 1, this symbol represents the inverse of element a under this notation, multiplicative notation. Here we have minus a, and this is additive inverse of a, and minus a represents the inverse of element a with the notation additive notation. For next, I'll put a question. Suppose S is set. Suppose S is a set. Suppose we have a set S, and we have 3 elements in this set, and star is given a binary operation, star a binary operation on S. It is a binary operation, star. Now it is given that find A star, B star, C. Find this one. Can you find A star, B star, C? Suppose we have the set of integers and binary operation is negative, and you have been given find 3 minus 2 minus 1. Can you find this one? See, this is not well defined first, because the operation we have, that is a binary operation, and binary operation knows how to operate 2 things. Suppose it is given to someone, he may operate 3 and 2 first. Suppose he is operating 3 and 2 first, he will get 3 minus 2, that is that is 1, and minus 1, he will get 0. And some other person, suppose he is operating 2 and 1 first, because there is no order, it is not given that you have to operate 3, 2 first or second. So anyone can operate in any way. So for 3 minus 2 minus 1, suppose someone is operating 2 and 1 first, then he will get 3 minus 1, which is 2. So this expression have 2 results, one is 0, another is 2. So there is ambiguity on finding this the element for this expression, the result of this expression. So finding this one is ambiguous. It is making confusion in which way, in which 2 elements I should operate first. It is not explicitly mentioned. That also happens for here. Star is any binary operation. We have seen subtraction is a binary operation. So this A star, B star, C is not well defined. Is not defined. So we have to be cautious. For any set, any random set, for any binary operation, if we have been given multiple elements with no parenthesis, no braces, and we have been given to find A star, B star, C, or A star, B star, C star, D, any 4 elements, and they are operated with the operation star, and that is not defined. Note it down. I will erase. So this is not defined for a random set and for random binary operation. If star is associative, if we have our binary operation associative, moreover we have a random set, a random binary operation, and that binary operation is given associative. Now suppose I have been given find A star B star C. Let me first find A star B, then operate that with C, or I can operate B and C first, then with A. Since this star is associative, no matter in which way I am doing this, because these are same, so if star is associative, I can unambiguously write this expression, and it is well defined. It is defined because there is no need to put parenthesis. We are not going to do some extra work, because in which way you will put parenthesis, you will get the same result. Suppose we have 4 elements A, B, C and D, and star is given associative. Here also we don't have to mention first operate this one, then this one, then this one. Let us suppose someone is operating B and C first, and then this one. Then the result he will operate that one with D. Now that will be also same as, since star is associative, it is same as A star B star C, because in this parenthesis we have A star B star C, and star is associative, so I can write A star B bracket star C, then star D. Also this is same as, I can take this one as one element, star C, so I can write A star B, this is one element, na? Star, this is one element, because star is associative, this is one element. Suppose this element is E star C star D, I can keep E, then star, operate C and D. So this is same as this one, this is same as this one, and it will turn out, in which way you are putting parenthesis, it will not matter. In every way you will get the same answer. So I will erase this one. So if star is associative, then we have any number of elements, and if they are operated under the operation star, and this is well defined, because it does not matter which two elements you will operate first, then with anyone. So this is well defined, this is defined on ambiguously, there is no confusion. So what we have, if we have a random set and star is random binary operation, then this expression is not well defined, because star may be associative and it may not be. If star is associative, then this expression is well defined. It is not needed to put parenthesis. in which way you will put parenthesis, you will get the same answer. And by repetitive use of associative operation, this is also well defined for any set of any number of elements under the operation star. Now I will erase this one. So what we have in a group G under the operation star, we have star is associative. So for any element G of this set, we have this product is defined because star is associative by the axiom subgroup. Since this is a group, star need to be associative, and this is defined. So this one has a special symbol in multiplicative notation and additive notation. Suppose we have A star A star A, these are n times A, n times. For this we have a happy little symbol, that is A to the power n, and it is power. And here we have n times A, and this will be understood as A plus A plus A plus A up to n times A, and times, this is times. Next we have suppose we have A star B inverse. I will write here as A star inverse of B. Inverse of B. Here you have to only write A B inverse. This is read as quotient, and here we have A minus B, which is difference. Please pause the video to note. Let me erase now the notations. So I can use any notation. I can use a happy big sun for my binary operation, and this is A when operated with my binary operation, or you can save space, time, or energy, anything you wish. So you can ask your doubt in comment section, and I will try my best to cover them in my next video. So thank you.